Well, AD, according to our diagram, is AB, BC, plus CD. I added a bunch of segments together to make a bigger segment.
Segment addition.
That's all it is. Do you have two things that are the same thing? Yeah. AD is the same thing as AD, isn't it? Last time I checked, are these the same two letters? Yes. Do they equal different things?
No. If AD equals AD, they're not different.
Do they equal, according to this, are they equal to two different things? So that means the two different things have to be equal to each other. That's it. It's the same stinking step with every single proof that we've done. You have two things that are the same, that are set equal to different things. You set them equal to each other. Yes, ma'am? BC what?
Oh, BC equals BC, the common.
You don't have to, because it doesn't hurt. It's not doing it. It's extraneous or erroneous. Erroneous. It's extra that doesn't have anything to really to do with what we're trying to show. We didn't have to define it because we're not necessarily adding it to both sides of an equal sign. That's really the only time you have to really make sure you have it. In this case, since we're looking at the actual segment addition, saying that it's part of the of what we're setting up, that's why it's okay not to have that. If it's there, whatever, no big deal. Okay? So now I just set these two equal to each other. What's the same on both sides? AB and a BC. How do you get rid of them? Subtract prop equal. And what's the last step? Just get rid of them. Make sure you guys are writing this down, okay? Make sure you're writing it down. It's not really on the computer. Okay? You gotta write this stuff down, guys. That's the whole idea. I'm watching people just sit there and watch me do these things. You're not going to do well on this stuff if you just sit there and observe. Yes, sir. Not necessarily. Depends on the problem. Each problem is different. Each problem is different from of itself because every problem has something to do. Yeah. Correct. Yes. You can say that for certain. All right. The beginning of every problem is always going to be a given, but the end of the problem isn't always necessarily a flip to a congruency. It could be. It might not be. It's really difficult to what they're asking to show. Yes, ma'am. For here, we have two things that are equal to each other, that are equal to two different things. So that means you set these two equal to each other. You can put one in for the other. That's it. When two things equal the same thing, they're equal to each other. These three segments both equal AD. So that means they have to equal each other. That's it. That's all it is. It's the same idea as writing this. AB equals 7, CD equals 7. They both equal 7. So AB has to equal CD. That's all it is. Two things that equal the same thing, they have to equal each other. Substitution, it happens over and over and over and over and over again. Okay? Given B is between A and D, C is between A and D. Bless you. what you have to understand is when you say that B is between A and D are what? The endpoints, yeah, they're the points, they're the endpoints. If B is between it, that means two segments are formed. Just thinking, if B is between A and D, well, if A and D are here, where does B go? Does it have to be in the middle? B is between A and D, okay? Thinking about that, the same idea, C is between A and D. Well, A and D are here. Does it matter where C goes? It just says it's somewhere in between it. It does not matter. If I look at this, just looking at this quick little diagram here, AD is now made up of what two segments? Here, AD is made up of what two segments? Hey, didn't we just write something down about two segments that both equaled AD? You just did the proof. So if B is between A and D, we just showed that you get this. AB plus BC, excuse me, BD is AD. The marker didn't cut. Sometimes it has there's a dead spot every once in a while there. Okay? It's not segment addition because of the given. Is it collinear?
Because they're collinear points.
Yeah.
Yes.
I would just go with the definition of collinear. It's a little bit different. What did I write? I don't remember. Did I write segment addition?
Yeah.
It won't be okay. Because it's telling you they're in between.
Right.
Yeah, segment addition is fine. Too small or equal to large. Because that's what it's showing. That's fine. Same deal. Do these two things equal the same thing? Yeah. So you just substitute in one for another. You set them equal to each other. Anytime you have two things that equal the same thing, they're always equal to each other. Always, always, always. And what's the reason? Substitution.
I do like that flow better. I always used to put my givens first and then break apart the givens. But I do like this flow a little bit better. But if somebody did that, is that okay?
It's perfectly fine,
Okay.
perfectly fine. The only thing that I always strive to try not to do that is because sometimes you might forget a given.
Oh, right.
That happens a lot more when we get to triangles because you might be given that you have an isosceles triangle and you might have an angle bisector. So you might forget to go
There's
back.
certain things,
Yeah.
right,
So that's the only reason that I don't do that, but there's nothing wrong with it.
okay.
Absolutely. Does that make sense, guys? What Mr. Roy was saying is that sometimes some people will just write down all the givens at once. The only suggestion that I have about not doing that is that you might forget one of the givens. That's all. So just be careful. If you're one that does that, just be careful to go always make sure that you utilize all the given stuff. So if you have like two givens that have definitions, let's say you have one that's midpoint, one that's an angle bisector. Make sure that you have somewhere in your reasons midpoint, definition, angle bisector. That way you can always kind of check yourself that you actually used that. Okay? That's the idea there. All right? Hey, a midpoint. Everybody should have gotten this one, because what's on your progression sheet? Midpoint. Convenient, don't you think? Your progression sheet? Well, you better take a picture of somebody else's and fill out a new one. You're gonna need it. You have to keep tabs on these things. Are you guys making sure you take pictures of them and back them up? Progression sheet's your best friend. It tells you everything you need to do.
I think you even said that on one of your notes at the start of the week. Good morning, geometry class.
I did.
Sure, yeah.
Yep. Did any of your parents ask you about progressions? Squares? I've done that before. There was a, oh geez, what class was it? It was, I think it was my honors algebra 2 class about 3 years ago. We were doing some simplifying of trigonometric equations, where it's a pain to simplify, verify trig expressions. And I sent out the email and I said, hey, if you want to be crazy, cut this worksheet up and paste it around the house to annoy your kids. Well, I had a couple of parents that quite literally did that. And I found out later when they came back from the weekend, or I think it was like a long weekend or something, and this one girl, she's like, are you kidding me? My mom hid these things everywhere. They were in the box of cereal, they were in the fridge, they were in my shoes when I tried to put on my coat. And then I had another parent call me back or email me and goes, what's the deal with all this? And she wrote out this hilarious email in terms of sines and cosines, and I was in tears. Of course, her kids were just embarrassed, but I thought it was hysterical. Anyway, what does your progression sheet tell you to do if you have a midpoint? What does it say? Segment, congruent segment, or segment equal segment. Which one do you think I would write down? Would I write down segment equal segment or segment congruent segment with this example? Equal. Why do you think I would use equal? Because there's equal in here. Does that make sense? It's okay to use either term because it just depends on what is coming up later. Now, if you chose one and then you realize you had to switch, could you always just use definition of congruency to switch it? Yeah, it's okay. But if you get the idea here, you're saying, oh, I noticed I'm going to have to do some addition later on, might as well just write it as equality because that's the only way that you can use math. So that means that AB equals BC. What's the reason? Definition midpoint. AB equals BC. It wants us to talk about something about segment BD. Well, BD, according to our diagram, is made up of what two segments? So BD, according to our diagram, BD is BC plus CD. What's the reason? Very good. Segment addition. Now, what can I replace? With what? AB. So now I'll replace BC and I'll just go with AB plus CD is BD. Am I going to yell at you guys if I flip-flop here? See how this says to have the plus sign first and here I had the equal sign first? It's not the end of the world if we don't do the symmetric property all the time. I'm going to be okay.
But you could, right?
Yes, you could.
If you plugged it in exactly the way you did it
Yeah.
and then did symmetric
Yeah.
property, okay.
Hey, I'm great if you figured this step out by doing substitution. That's all it is.
See, that's pretty.
I just want you guys to try. I mean, seriously, you had to come up with one step on your own here. One step. And that was the substitution step. That's it. Okay. Because everything else was right out of the diagram. Or was it given? Last one. Bless you. Last one goes into the angles. When you look at your given versus what you have to show, look at your diagram. According to your diagram, you have angle AEC is congruent to angle DEB. So according to our diagram, we have two larger angles that are congruent to one another. We want to show that the two smaller angles are congruent to each other, which means, what do you have to back out? We're going to back out the middle wedge. This is the example of not adding the middle wedge. It's the example of subtracting the middle wedge. Now, if we did subtraction, we had to be in what? Equal. So, first thing we should do here is switch from congruent to equal. So what I'm looking at now, we have two larger angles. Each of those two larger angles are made up of smaller angles. So how can I rewrite AEC in terms of two smaller angles?
AB,
Yeah.
AB plus BC.
We're not segments, buddy. It's angles. Angle AEB plus
Angle
BC equals the bigger.
Angle BC.
So angle AEC is made up of the two smaller angles, AEB and angle ABEC. So what is it when you have two smaller angles make up a bigger one? Angle addition. Now, I don't mean to harp on you guys about all this stuff, but can you start to see that it's kind of the same problem over and over and over again? There's not a lot of variance here, guys. We only know really two things, angle addition and segment addition. Okay? That's all we know how to work with as of yet. We haven't learned anything else new. It's the idea that you can trust yourself that you can try it. Okay? That's the big thing. You've got to take the chance.
So the next step is angle BEB.
It's made up of what, too, Whiskey?
Angle BEC plus CED.
Very good. Do I have two angles that are equal to each other that are set equal to two other parts? So those two other parts have to be very good. Now the only thing that I dislike about angle proofs, so many letters. You just gotta be careful when you're writing it out. That's about the worst that happens with these things. You get a lot of letters, and it can get kind of messy if your handwriting isn't careful. So we know that these two have to be equal to each other because these two are equal to each other. So we just write it out.
That's your substitution process.
Very good.
Dang, this is impressive.
There's your substitution. And then what do they have that's the same on both sides? BEC. There's your middle wedge. R's. There's the middle wedge that you just subtracted out, and you're left with your two smaller angles on the outer edge. That's how these work. Yes, did it ask us to put it in congruent or equality? Equality. Hey, they wrote it as DEC. As of right now, we have it as CED. Is it okay? Or am I going to yell at you that you didn't do a symmetric property for the one angle?
Yes. Yes.
No,
No,
it's
you won't.
it's
You're
it's
nice.
okay.
Oh,
All
really?
right. Fine with me. And the other two letters are C and D. So then we have, this was the sub T, prop equal. And then finally, switch.
Subtraction.
I really don't want you guys to be scared of these
Definition
things.
of complement. I mean,
Did this help you guys
I
going
mean-
over those, breaking those down?
somewhat, not really.
I mean,
It helped a little bit.
it's not meant to be scary. It's not meant to be frightening for these things. It's not meant to be crazy stuff. It is just a different way of thinking. It's a different way of organizing and putting things on paper. That's all it is. When it comes down to it, it's the idea that it's different math. This isn't normal add, subtract, multiply, divide. This is logic, reasoning, putting things together. Argument. You're teenagers. You guys like to argue, right?
No.
Don't argue with me.
I do.
Listen, I don't. Yeah, all right. Point in case. So,
Whiskey likes argument.
this idea of having the sheet here, by having this with you, by reading through this stuff, this is your logical argument. This is what you're able to argue with. This tells you how to set things through. Yes, ma'am. Yes, ma'am. There are 4 questions. Okay? Yeah. So we have more of these because, we can never have enough practice. And I believe that the stuff that we're looking through, and setting for like quiz-wise, we have fill in the blank, we have algebra, and we have segment angle stuff on your own. So start thinking, there's 4 stuff. Everybody but you.
Okay, sorry.
Yes, that's the whole point of having the progression sheets. I wanted you guys to have the map of what to do, because that's how you keep your thoughts straight. There's so much material here that I can't expect you guys to try to keep all of it in check. It's too much stuff straight up, okay? But if we have them in smaller chunks, if we're able to look through them in smaller pieces and be able to reference stuff, it's gonna make your lives easier, okay? So let's start looking at a few of these to get this thing up. Oh, I don't have this on here? Oh, I guess I don't have it. Oh well, I'll have to read one. All right.
You wanna read mine?
I'll just grab another one. All right, let me grab one. do is flip over, and I'm going to look at number 10 first. And I apologize. For some reason, I must have forgotten to scan this, so
It's okay.
you'll have to look at my awesome drawings. Yeah, it does.
It's killed us, it's killed us.
All right, let's start with number 10. I think out of all of these that are on here, this might be the most complex because of what you're given. So on your progression sheet, you have something about perpendicular. I hope. If we have something about perpendicular, I believe it probably has this bit of information. If given perpendicular, we probably did this. Blah, blah is perpendicular, blah, blah, given. Then we would state right angles that are formed. Definition, perpendicular. Then we would say that right angle equal or congruent to right angle. And our reason was all right angles congruent. Now, that's probably what you have on your progression sheet. I also think that you might have something on there about right angles. You have one of two things. You might have something on there that says that if you have two right angles that are formed, you might have say that they're equal to each other. If you have one right angle that is formed, you might have something that just says set it equal to 90. So when you get to perpendicular stuff or right angle stuff, you have to be very cautious as to make sure what you're going to follow through with. So let's see what happens. We have OA is perpendicular to OC.
That's what they do. That's
So OA perpendicular to OC. There's our given. So that means that we have a right angle there. What is the angle that is formed with that? Because it says OA is perpendicular to OC.
And then look at the progression sheet. What should have, if given perpendicular.
So,
What's the right angle that's formed?
angle 90 on right angle.
AOC. So and I can say angle AOC is a right angle. How do I know that? Because it's perpendicular. What's your progression sheet say? Get your progression sheet out. I'm like talking to a wall here. Come on, man. It tells you right to do. Sir. Yeah. Now, we only have the one angle here. So I think on here it said if we have just the one, what will we say? It equals 90 degrees. Let's just do that. I think that might be our best bet here. And then that's a definition of a right angle. Okay? I'll do the same exact setup with, oh, excuse me. Should I do the next given first, or if I look at my diagram, what do I know that AOC is made up of? Look again. This one's nice though. You're right, it's AOB and BOC, but it gives you numbers. It's nice when it is that. So angles 1 and 2 have to add up to equal what? It has to equal 90 degrees. These two angles form the right angle, which means that angles 1 and angle 2 equals 90. What's the reason?
I thought you were gonna say something.
Well, forgot the step here. You're right. You were right with the substitution. I forgot to say that it was that first. AOC is made up of that. We said it out loud. I just didn't write it down. There's our there's our angle addition. And now that I know that these two are the same, I can now say that at angle 1 and angle 2 equals 90, because just like you said, there's our substitution.
You want to hit somebody first.
Now, perpendicular ones take the longest to go through because there are so many things that you can write. That's the only downfall of them. Once you see what's going on, they're relatively straightforward because you're going to get 90-degree angle. You might have two of them, you might have one, depending upon what the diagram looks like. And then you just have, in this case here, we knew that we were marked up as two angles that make up the angle. So when you see that in the diagram, you're saying, hey, I should write that down and go from there. Now, basically what I'm going to do is replicate those 5 steps with the other.
So you would recommend doing them at the same time?
No, this is a prime example of probably not doing everything at the same time because it's so easy to miss it.
Okay.
Does everybody understand that? See how this one given generated these 4 steps? And you're right, and it's exactly right. The other given is the same thing, but just will wind up with different letters and different numbers. Just when you look at the diagram. Does that make sense? So what's going to happen here is we're going to switch and write everything in terms of the other two. And this turns out to be pretty much the exact same problem we did, you don't have your notes out. What was the one where you had to subtract out the middle? It works out to be basically the same problem, but you just have a little more complexity because of the perpendicular. That's all. So, bless you. Let's rewrite everything out in the next step. We have OB. OB, what is it to OD? So that means that we have angle BOD. Definition of perpendicular. That's where I'm at here. And then what's that last one to write then after I wrote down BOD is made up of 2 and 3? That angles 2 and 3 have to also add up to equal what?
So that's definitely 2 and 3.
What's that last step in blue, guys?
Angle 2 and 3 equal 90.
Very good. I'm going to slide this up a bit here. So now, look what we have.
I wrote too big, that's
So we have 2 things that equal the same thing. What can you say about those 2 things then?
no. Still equal one.
Hey, well, let's do it quite literal what you see here. They both equal 90, right?
Yeah.
So I'd say 1 and 2 equals 2 and 3. I thought you said 1 and 3. I'm sorry, I thought I heard you say 1 and 3. That's my fault. Yes, you're right. So now I have 2 things that both equal 90.
But 1 and 2 is equal to 3. 2 and 3 equals to 5.
Hey, Whiskey, we're not worried about that right now. I understand you're trying to be cute, but a lot of people are trying to figure this out, so let's not do that. And well, almost there. What do they have to say? Let's on both sides.
2.
Cross them out. Why?
Because they're the same.
They're the same. Very good. What's my reason, Mr. Pitts?
Huh?
Huh?
She was talking.
Oh, what's the reason? You're right, they're the same. Why can I back them out? What am I doing to both sides?
Equal subtract.
Sub t prop equal. Well, that's you? Well, it's not substitution. Remember, we don't write substitution with the t. We write out the word substitution.
Sub. Did we just put sub?
No. Guys, that's like the most complex one I think we've ever done because of the two different perpendiculars, because there's so much info there. And going back, we probably could have shortened it a little bit. Because we knew, once we got to the angles, we might have been, because we had right angles, we could have said right angles, we might have been able to shorten a couple of steps, but I don't think it would have flowed as nicely. This might be one, if it's this complex, that I would have you fill in the blank. Okay? This more simplistic style, you could do on your own. Let's look at an example, one of the, or we're running out of time, aren't we? All right. So, I know that when I was looking at this stuff here, I would, numbers 1 and 3 and numbers 2 and 4 are basically identical to one another. 1 and 3 and 2 and 4 are identical to one another. And then, yeah. Let's see, 2 and 4. Number 5 is a really good one.
Which one is it?
No, I would go up through 6. Go up through 6, guys. Go up through 6.
1 through 6.
All right.
1 through 6.
Go 1 through 6, basically the first page. And remember, 1 and 3 are basically the exact same problem. 2 and 4 are also basically the same problem. On number 6, I will give you a hint. On one of your progression squares, you probably have something about vertical angles. What do you know about vertical angles? That they're congruent. I would look for vertical angles on number 6. I believe number 6 is only about, what was it, 4 steps? Yeah, most of these are under 6 steps, right? I believe. I think all of them should be under 6. I think they're all under 6? 6 are under, okay. So that's about the complexity we're trying to keep these at, okay?
4 and 5 are a little bit longer,
4 and 5?
because you're going from.
Oh yeah, congruency to equal, and yeah, you might get extras in there. Complementary, you have a couple extra things because you have to say that they add up to 90. That's all your progression. Okay? You guys are gonna be all right. You have to trust that you can do it.
That picture was from like.
You gotta watch this.
Of course.
I don't know if they're gonna do it though.